Hi everyone, welcome back to my channel. So we are solving the CBSE 2026 Maths Standard Paper Set 1 Section B, and this is the question number 24. If tan theta plus 1 by tan theta is equals to 2, then find the value of tan square theta plus 1 by tan square theta. Okay, so this question is from trigonometry, which is a very easy question. So let's see. What is given to me is tan theta plus 1 by tan theta is equals to 2. So let's do the squaring on both sides so that we can apply the identity. Whole squared. Sorry, this is 2 square, that will be 4 here. And let's see what we get. Tan square theta plus 1 by tan square theta plus twice of tan theta into 1 by tan theta. Okay, so what we have done here, a square plus b square plus twice of ab, that is equals to 4. Now this is going to cancel, and finally the value of tan square theta plus 1 by tan square theta, that is equals to 4 minus 2, and it is equals to 2. Okay, so what is the answer for this question? 2 is the answer. Okay, and here we have the b part also. This is also from trigonometry. Let's see. So we have to prove that LHS, which is square root of 1 minus sine theta divided by 1 plus sine theta, it is equals to secant of theta minus tangent of theta. Okay, so let's see the solution here. LHS is equals to square root of 1 minus sine theta divided by 1 plus sine theta. Okay, so whenever we have something like this, what do? We will do the rationalization. So let's extend this and we will do the rationalization here by 1 minus sine theta in the numerator as well as the denominator. Okay, so in the numerator we are getting 1 minus sine theta whole square divided by again a square minus b square, so that is 1 square minus sine square theta. Okay, so this is the whole square root. Now 1 minus sine theta will be, sine theta whole square will be there, divided by, we know the identity. In the denominator we have 1 minus, this value will be reduced to 1 minus sine square theta, which is nothing but cos square theta. From the identity, sine square theta plus cos square theta, it is equals to 1. Okay, so 1 minus sine square theta will be cos square theta. So let's put the value here. If these values comes out of the bracket, we will get 1 minus sine theta divided by cos theta. We will separate the value, so we are going to get 1 by cos theta minus sine theta by cos theta. What is 1 by cos theta? We know that it is secant of theta, minus sine theta by cos theta, it is tangent of theta. Okay, so hence this is equals to the RHS. This is how you solve this question. Okay, I hope it is clear to you. Let's see the next one now. Okay, the next one is, in the given figure, O is the center of the circle. O is the center of the circle and PQ and PR are the tangents. Show that the quadrilateral PQOR is cyclic quadrilateral. Okay, so this question is from the chapter circles and this is a standard question. Let's see how do we prove this. Okay, so what is the property of a cyclic quadrilateral? We know that in a cyclic quadrilateral, the opposite angles are supplementary. Okay, so what we have to prove in this question is these two opposite angles, this one and this one, they are supplementary angles, which we have seen in some of the questions previously. Now let's see how do we prove it. The proof is also very similar. Okay, we know that this OR is perpendicular, this OQ is also perpendicular, right? So we can write here this OR is equals to OQ. They are the radius, right? And by the theorem number 1, we know that perpendicular at the point of contact, radius is perpendicular to the tangent at the point of contact, right? So we can write it like this: OR is perpendicular to PR and OQ is perpendicular to PQ. Okay, so that is your, that can be visible from here. If that is the case, then we can write, therefore this angle ORP is equals to O angle OQP, that is equals to 90 degrees. Okay, both the angles here are equals to 90 degrees. This is 90 degree and this is 90 degrees. See, it is clearly visible from here that if these angles are 90 degree, then what is remaining is, this is a quadrilateral. Total sum is 360. 360 minus 180, that will be what? 180. So we can directly write this, but yes, we have to prove this in detail. Okay. So what we are going to write is, we know that the sum of interior angles in a quadrilateral is always equals to 360 degrees. So we can write, in the quadrilateral PQOR, angle OQP, this is 90 degrees, plus angle QOR plus angle ORP plus angle RPQ, that is equals to 360 degrees. Now ORP and OQP are equals to 90 degrees plus QOR plus, this is 90 again, RPQ, that is equals to 360 degrees. So what we have to write here is, this is 180, angle QOR plus angle RPQ, it is equals to 360 minus 180. So angle QOR plus angle RPQ, that is equals to 180 degrees. Okay, so we can say that this angle and this angle are supplementary angles, and that is the property of a cyclic quadrilateral. Opposite angles are supplementary, right? So we can say that yes, PQOR is a cyclic quadrilateral. Okay, so this is how you have to prove it. I hope this is clear. So with this, we have finished the section B. Very short questions, all 21 to 25 we have finished, right? So please like, share and subscribe the channel so that you can get the notification of the upcoming videos. So see you in the next one. Till then, keep learning, keep smiling and have a great day ahead. Thank you.